For this activity, what we were being asked to do was to look at the solid that has 0 on the bottom and an upside down ball on the top. They give us a density function, and they're asking us to find the mass of S. Now, I'm going to do this as a triple integral, remembering what the graph is supposed to look like and what the integral is supposed to look like. We know that if we're finding mass from the last video, we're supposed to have a triple integral. I'm going to try to leave some room for the limits of integration. I know the density function has to go right here. And then we need to do some sort of order of integration. Since both these functions are given by z, I'm going to do dz first. Now, following the pattern that we do for rectangular coordinates with double integrals, I want to start drawing lines that are parallel to the z-axis. So, for example, here's one, parallel to the z-axis. And I want to know what is z as that line enters the region, and what is z as that line leaves the region. Well, when it enters the region, it's entering at z equals 0. It's leaving at the bowl, 25 minus x squared minus y squared, like that. And so I can put in the limits of integration. This is going to be 0. This is going to be 25 minus x squared minus y squared. Now what needs to happen next is what I generally call smush. Not sure what color I want for smush, but for the moment, what happened? The problem is, basically, we want to collapse this so that the z doesn't mean anything at all. We're actually going to be looking at a bird's eye view of what happens when we smush this down. Now, when I smush this down, we're now going to be in the xy plane. It's going to look like this. It's certainly going to look like a circle. That circle has an equation, and we get that equation by taking the Bowles equation and asking what would happen if we set the z values equal to 0. Well, what we're going to get is x squared plus y squared equals 25. So that's just going to tell me that the radius is going to be 5. Now, if we're doing this in rectangular, the next thing we want to do is start drawing lines parallel to one of the other axes. I'm going to do y next, so it's going to go like this. I need to know the labels of those 2 points. I can see that those 2 points have the same x coordinates, so I know I want x comma something, and I want x comma something. Now, how am I supposed to get that? Well, we know the equation is x squared plus y squared equals 25. So the y coordinate on the circle, because that's what I'm looking for here, is plus or minus the square root of 25 minus x squared. That makes this one down here minus the square root of 25 minus x squared, and up here the positive square root of 25 minus x squared. Remember, those give us the limits of integration for y. So this is going to go dy like this, and this is going to go from negative the square root of 25 minus y squared to the positive square root of 25 minus y squared. Let me move this one back so we can see what's going on. We now need the limits of integration for x. That's the last thing we're going to have to find here. Now, if we're doing double integrals, basically we don't have to do any more smushing. We don't have to do any more smushing here either. I would just have to know what's the location of the chops, but we can actually do some smushing here. So what I'm going to do is say smush here. And what are we smushing to? Well, y can no longer be relevant. So we're actually just smushing everything to the x-axis. All that's going to be left is an interval on the x-axis that goes from 5 down to minus 5. And so that's going to give us the limits of integration for the most outside integral. Oops, I want minus 5 to 5. There we go. And that's how we set up a triple integral. One thing you're going to need to know, by the way, is we have to have that picture. Very often, we can't tell actually what's going to hit and what's going to not hit until we actually draw the picture and then draw the line and see where those points enter the region and see where the points where the thing leaves the region. This is where we actually have to do our visualizing. This is where actually the graphing starts to get vital. So be prepared.